NEC Article 300.37 mandates that conductors installed in multiple raceways must have equal lengths. This is a critical requirement when dealing with parallel conductor installations. The purpose of this requirement is to ensure that each conductor carries its fair share of the total current. Unequal lengths would result in differing impedances, leading to unequal current distribution and potential overloading of some conductors, creating an unsafe and inefficient system. NEC Article 300.4 permits the use of multiple raceways for conductors of the same circuit if the raceways are accessible. Accessibility is key because it allows for inspection and maintenance of the conductors in raceways. If the raceways are buried or concealed, it becomes difficult to verify the condition of the conductors and to perform any necessary repairs or replacements. Given these NEC provisions, it is permissible to use 4 underground conduits and 2 overhead conduits for a 2000 amp 480 volt feeder, provided that the installation meets specific conditions. Firstly, the conductors in all 6 conduits must be of equal length. This is the non-negotiable requirement of NEC Article 300.37. The equal length ensures equal impedance and balanced current distribution. Secondly, the raceways must be accessible as stated in NEC Article 300.4. This means that the underground conduits must have accessible pillboxes or manholes at reasonable intervals, and the overhead conduits must be readily accessible for inspection and maintenance. Thirdly, all other applicable NEC requirements must be met. This includes, but is not limited to, proper conductor sizing, appropriate insulation type for the environment, proper grounding and bonding, and compliance with all applicable ampacity tables and erecting factors. When considering the use of both underground and overhead conduits, there are several practical considerations to keep in mind. One consideration is the potential for different environmental conditions. Underground conduits are typically subject to moisture and temperature variations, while overhead conduits are exposed to sunlight, wind, and temperature extremes. These differences can affect the aging and performance of the conductors. Therefore, it is important to select conductors with insulation that is suitable for both environments. Another consideration is the potential for physical damage. Underground conduits are susceptible to damage from digging or excavation, while overhead conduits are vulnerable to damage from storms, falling objects, or vehicle collisions. It is important to protect the conduits from physical damage by using appropriate materials and installation methods. For example, underground conduits can be encased in concrete or buried at a sufficient depth, while overhead conduits can be installed at a safe height and protected by guards or barriers. The transition between underground and overhead conduits also requires careful attention. The transition point should be located in a readily accessible location, and the conduit should be properly sealed to prevent moisture from entering the system. The conductors should be supported and protected at the transition point to prevent strain or damage. When calculating the required conductor size, it is important to consider the total current of the feeder, which is 2000 amps in this case. The NEC provides ampacity tables that specify the allowable ampacity of conductors based on their size, insulation type, and temperature rating. It is important to select conductors with an ampacity that is sufficient to carry the total current of the feeder, taking into account any applicable derating factors. Derating factors may be required if the conductors are installed in close proximity to each other or if the ambient temperature is high. These factors reduce the allowable ampacity of the conductors to prevent overheating. The number of conductors in each conduit should also be carefully considered. The NEC limits the number of conductors that can be installed in a single conduit to prevent overheating and to ensure that the conductors can be properly cooled. The allowable number of conductors depends on the size of the conduit, the size of the conductors, and the type of insulation. It is important to consult the NEC tables to determine the maximum number of conductors that can be installed in each conduit. Grounding and bonding are essential for the safety and performance of any electrical system. Grounding provides a low impedance path for fault currents to return to the source, which helps to trip over current protection devices and prevent electrical shock. Bonding connects all non-current carrying metal parts of the electrical system together to create an equipotential plane, which minimizes the risk of electrical shock. The NEC specifies detailed requirements for grounding and bonding, including the size and type of grounding and bonding conductors, the methods of connecting the conductors to the equipment, and the location of the grounding electrodes. Overcurrent protection is also crucial for the safety and reliability of the electrical system. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current in the event of an overload or short circuit. The NEC requires that overcurrent protection devices be sized to protect the conductors from overheating and to prevent damage to the equipment. The size of the overcurrent protection devices depends on the ampacity of the conductors and the type of equipment being protected. Coordination of overcurrent protection devices is also important to ensure that the device closest to the fault trips first, minimizing the extent of the outage. In addition to the technical considerations, there are also regulatory and permitting requirements that must be met. Electrical installations are typically subject to inspection by local authorities to ensure compliance with the NEC and other applicable codes. It is important to obtain the necessary permits and to schedule inspections at the appropriate stages of the installation process. Failure to comply with these requirements can result in fines, delays, and even the shutdown of the electrical system. To summarize, using 4 underground conduits and 2 overhead conduits for a 2000 amp 480 volt feeder is permissible under the NEC, provided that the following conditions are met. Firstly, the conductors in all 6 conduits must be of equal length to ensure balanced current distribution. Secondly, the raceways must be accessible for inspection and maintenance. Thirdly, all other applicable NEC requirements must be met, including proper conductor sizing, insulation type, grounding and bonding, and overcurrent protection. It is also important to consider the environmental conditions, potential for physical damage, and regulatory requirements. By carefully planning and executing the installation, it is possible to safely and reliably supply power to the MCC using a combination of underground and overhead conduits. Now let's delve deeper into specific aspects of this type of installation. When selecting the type of conduit, options include rigid metal conduit, intermediate metal conduit, electrical metallic tubing, rigid polyvinyl chloride conduit, and reinforced thermosetting resin conduit. Each type has its own advantages and disadvantages in terms of cost, weight, corrosion resistance, and ease of installation. For underground installations, rigid polyvinyl chloride conduit is often preferred due to its excellent corrosion resistance. However, it is important to ensure that the conduit is buried at a sufficient depth to protect it from physical damage. For overhead installations, rigid metal conduit or intermediate metal conduit are commonly used due to their strength and durability. However, it is important to protect the conduits from corrosion, especially in coastal areas or industrial environments. When pulling the conductors through the conduits, it is important to use a lubricant to reduce friction and prevent damage to the insulation. The pulling force should be kept within the limits specified by the conductor manufacturer to avoid stretching or breaking the conductors. It is also important to avoid sharp bends in the conduits, as these can increase the pulling force and damage the conductors. The NEC specifies minimum bending radii for conduits based on their size and type. After the conductors have been pulled through the conduits, they should be properly terminated at both ends. The termination should be made in accordance with the manufacturer's instructions and the NEC requirements. It is important to ensure that the connections are tight and secure to prevent overheating and arcing. The conductors should also be properly identified with labels or color coding to indicate their function. Before energizing the feeder, it is essential to perform a thorough inspection and testing of the installation. This includes verifying the continuity of the conductors, testing the insulation resistance, and checking the grounding and bonding connections. It is also important to verify the operation of the overcurrent protection devices. If any defects are found, they should be corrected before energizing the feeder. Once the feeder is energized, it is important to monitor its performance to ensure that it is operating within its design parameters. This includes monitoring the voltage, current, and temperature of the conductors and equipment. Any unusual reading should be investigated and corrected promptly. Regular maintenance is also essential to ensure the long-term reliability of the feeder. This includes inspecting the conduits and conductors for damage or corrosion, tightening the connections, and testing the overcurrent protection devices. Any necessary repairs or replacements should be made promptly. Let's consider some specific scenarios that might arise during the installation or operation of the feeder. Suppose that one of the underground conduits becomes damaged due to excavation. In this case, it would be necessary to repair or replace the damaged conduit. The repair should be made in accordance with the NEC requirements and the manufacturer's instructions. If it is not possible to repair the conduit, it may be necessary to replace it with a new conduit. Alternatively, it may be possible to reroute the conductors through the remaining conduits, provided that the ampacity of the conductors is sufficient and the number of conductors in each conduit does not exceed the NEC limit. Suppose that one of the overhead conduits becomes damaged due to a storm. In this case, it would be necessary to repair or replace the damaged conduit. The repair should be made in accordance with the NEC requirements and the manufacturer's instructions. If it is not possible to repair the conduit, it may be necessary to replace it with a new conduit. Alternatively, it may be possible to reroute the conductors through the remaining conduits, provided that the ampacity of the conductors is sufficient and the number of conductors in each conduit does not exceed the NEC limits. Suppose that the current in one of the conductors exceeds its ampacity. In this case, it would be necessary to reduce the load on the feeder or to increase the size of the conductors. The ampacity of the conductors should be determined in accordance with the NEC tables and any applicable directing factors. If it is necessary to increase the size of the conductors, it may also be necessary to replace the conduits with larger conduits to accommodate the larger conductors. Suppose that the voltage at the MCC is too low. In this case, it would be necessary to increase the voltage at the source or to reduce the voltage drop in the feeder. The voltage drop in the feeder can be reduced by increasing the size of the conductors or by reducing the length of the feeder. It is also important to ensure that the connections are tight and secure to minimize voltage drop. Remember that safety is paramount when working with electrical systems. Always to energize the feeder before performing any work. Use appropriate personal protective equipment such as gloves, safety glasses, and insulated tools. Follow all applicable safety procedures and regulations. If you are not qualified to perform the work, hire a licensed electrician. In conclusion, the installation of a 2000 amp 480 volt feeder using a combination of underground and overhead conduit requires careful planning, execution, and adherence to the NEC requirements. By following the guidelines outlined in this discussion, it is possible to safely and reliably supply power to the NCC. Keep in mind that local codes and regulations may vary, so it is always best to consult with a qualified electrician or electrical engineer to ensure compliance. Consider consulting with the local municipality or authority having jurisdiction to confirm any additional code interpretations that may be present. Careful consideration and meticulous attention to detail will result in a safe and compliant electrical installation.